This video is about solving problems using probability formulae. So just as a recap, let's go through all the formulae that we should know for this topic. So probability of A union B is equal to probability of A plus probability of B minus probability of A intersect B, which is the addition formulae, which is the same thing, equivalent to probability of A intersect B is equal to probability of A plus probability of B minus the probability of A union B. Okay, if A and B are mutually exclusive events, then that means probability of A union B is equal to probability of A plus probability of B. Also, probability of A given B is equal to probability of A intersect B over probability of B, which is the same thing as saying probability of A intersect B is equal to probability of A given B times probability of B. If A and B are independent events, this implies probability of A intersect B is equal to probability of A times probability of B, and also that probability of A given B is equal to probability of A, and probability of B given A is equal to probability of B. So it doesn't change if one event happens before the other. Okay, so please try to remember these before obviously you attempt probability exam questions. Let's go through some questions now. So two events A and B are such that probability of A is equal to 0.7, probability of not B is equal to 0.8, and probability of A union B is equal to 0.8. Find probability of A intersect B. So again, I think we're going to use the addition formulae. So probability of A intersect B is equal to probability of A plus probability of B minus the union. Probability of A is equal to 0.7. Probability of not B is equal to 0.8. So probability of B is equal to 0.2 minus the union, which is 0.8, which gives us a value of 0.1. Illustrate the above in a fully completed Venn diagram. So we got A and B. The intersect is 0.1. Probability of A is 0.7, so just A will be 0.6, because it has to add up to 0.7. Probability of B is 0.2, so this must be 0.1, so the outside must be 0.2. C, part 1, determine probability of not A intersect B. Oops, undo. Not A intersect B is just B, which is 0.1. And 2 is probability of not A union not B. So not A union not B is everything that's not A first. So not A means this one and that one. And everything that's not B is this one and this one. So anything that's shaded in, we have to add it together, because if it's one or the other or both, then it's included. So it means it's going to be 0.6 plus 0.1 plus 0.2, which is equal to 0.9. Okay, next question. Given that probability of A is equal to 0.35, probability of B is equal to 0.45, and probability of A intersect B is equal to 0.13, find probability of not A intersect, not A given not B. So the best thing to do is draw a Venn diagram for this first. So if we got A and B, we know the intersect is equal to 0.13. Probability of A is 0.35, so that means 0.35 take away 0.13 is 0.22, so this part must be 0.22. Probability of B is 0.45, so 0.45 take away 0.13 must just be B, which is 0.32. If you add all these together, you get 0.67, so the outside bit must be equal to 0.33. Okay, if A is find probability of not A given not B is equal to probability of not A intersect not B over probability of not B. Not A intersect not B is outside bit, which is 0.33. Probability of not B is 0.55, which is equal to 0.6. Explain why the events A and B are not independent. So if I do probability of A times probability of B, it's 0.35 times 0.45, which is equal to 0.1575, which is not equal to 0.13, which is equal to probability of A intersect B. Since probability of A times probability of B is not equal to the intersect, therefore A and B are not independent. The event C has probability of C is equal to 0.2. The events A and C are mutually exclusive, and the events B and C are statistically independent. Draw a Venn diagram to illustrate the events A, B, and C given the probabilities for each region. So C, so we're going to have 3 circles now. So what we do know is A and C are mutually exclusive, so they do not intersect. So A and C I would keep separate. A and C. A intersect B is 0.13, and they've said B and C are independent, so they're going to intersect. So B would be in the middle like this. Okay, so the first thing I do is probability of B intersect C is probability of B times probability of C, which is 0.45 times 0.2, which is equal to 0.09. So what I do know is the intersect is 0.09. We already worked out that the A intersect B, or they're given us A intersect B is 0.13. Probability of just A is 0.35, take away 0.13, which is 0.22. Probability of C is 0.2, so this part, just C must be 0.11. Probability of B is all equal to 0.45, so we already have 0.22 there, so it must be 0.23 in the middle. If we add all these numbers together, we end up getting 0.88. So this must be outside must be 0.22. 0.78, sorry, we get 0.78. Okay, part D. Probability of B union C not. So if I shade in B union C is this, 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 this. So this is B union C. So everything that's not B union C is unshaded region, which is equal to 0.22 plus 0.22, which is equal to 0.44. The events A and B are such that P of A is equal to a half, P of A intersect B is equal to a quarter, probability of not A intersect B not is equal to 2/3. Okay, so I just find this last one confusing. So if I draw this out, we've got A and B. So not A intersect B will be equal to not A intersect B is just this part. Sorry, no. So not A intersect B is this part. So the complement of that is everything else. So that means if I just color it in blue, then that would be everything apart from that green part. So that is that. Okay. Find probability of B. Okay, probability of B is equal to these two parts, that part plus that part, which is equal to probability of A intersect B minus probability of B intersect not A. Now A intersect B is just 2/3. So A intersect B is just a quarter. And B intersect not A is just going to be 1 minus, plus, sorry. So 1 minus the blue part, which is 1 minus 2/3. So if we put that into calculator, it's the same thing as a quarter plus a third, which is equal to 7/12. So I'm going to repeat it again. So probability of B is the two parts that I've just written, coded with stars. So A intersect B is just a quarter. The green part is 1 take away the blue part, which is just 2/3. When you simplify that, you get 7/12. B is illustrate the probability of subspace space of A and B in a suitably labeled fully completed Venn diagram. So now we know A intersect B is equal to a quarter, so this is a quarter. Probability of A is a half, so that means that must be a quarter. Probability of B is 7/12, so 7/12 take away a quarter is a third, so this is just a third. The outside bit must be 1 take away a quarter, take away a quarter, take away a third, which is 1/6. Part C, given that at most one of the two events occurred, determine the probability that event A did not occur. Probability A did not occur given at most one of two events occurred. Probability that A did not occur is just a third plus a sixth, so that's the probability of not A. And the probability that at most one of two events occurred is a quarter plus a third plus a sixth, so we can't have both of them occurring. So it's over a quarter plus a third plus a sixth, which gives us 2/3. Next question. The events A and B are such so that probability of A is equal to 3/5, probability of B given A is equal to a sixth, and probability of A given B is equal to 3/13. Determine the value of probability of not A intersect not B. So we've got probability of B given A is equal to a sixth, which implies probability of B intersect A over probability of A is equal to a sixth, which means we know what B intersect A is. Sorry, we know what probability of A is. So probability of B intersect A over 3/5 is equal to a sixth, which implies probability of B intersect A is equal to a 6 times 3/5, which is equal to 1/10. Now using the next one, which is probability of A given B is equal to 3/13. This implies probability of A intersect B over probability of B is equal to 3/13, which implies that we know what A intersect B is now from the previous working out. So 1/10 over probability of B is equal to 3/13, which means probability of B is equal to 1/10 divided by 3/13, which is equal to 13/30. So now we know probability of B, we've got probability of B intersect A, and we've got probability of A. So I can use it to find probability of A union B. So probability of A plus probability of B minus probability of A intersect B, which is equal to 3/5 plus 13/30 minus 1/10, which is equal to 14/15. So that means if I have my Venn diagram AB, then I know all of this shaded part is equal to 14/15. So probability of not A intersect not B is the unshaded part, unshaded region, which is equal to 1 take away 14 over 15, which is equal to 1 over 15. Okay, next question. A regular daily bus service leaves Voda bus station and arrives in Holston bus station sometime later on the same day. From its scheduled departure from Voda, the bus will either leave, so departure time from Voda will either leave on time or late, but never early. From its scheduled arrival time to Holston, the bus will either arrive early, on time, or late. So 3 options for arrival time at Holston. If the bus leaves Voda on time, the probability it arrives in Holston early is 4% on time. Early is 4%, on time is 52%, and late is 21%. The probability that the bus arrives in Holston early is 6% and on time 69%. So then we need to work out some probabilities. So I think the best thing to do is do this via a two-way table. So we have 2 things, which is departure time leaves from Voda, and there are 2 options. It's either on time, or late. Okay, now those are the 2 options. And then we have arrives at Holston, and we've got 3 things. It arrives early, on time, or late. Okay, so those are our options. We know, so these are the totals. We can have totals at the end. So total here and total there. So from its scheduled arrival time to Holston, okay, if the bus leaves Voda on time, the probability arrives in Holston early is 0.04. So we know early, on time, leaving on time and arriving early is 0.044%. On time will be 0.52 and late is 0.21. Okay, so the total, if we add this all together, I get 0.77, which means this must be 0.23. It has to add up to 1 because it's probability. Okay, probability that the bus arrives in Holston early is 6%. So total early is 0.06 and on time is 0.69. If we add that together, you get 0.75. So this must be 0.25. So the missing value here must be 0.02. There must be 0.17. And there must be 0.04. Okay, part A. Given that the bus arrives early in Holston, determine the probability that it left Voda on time. So probability Holston on time given Voda early. No, Voda on time, sorry. Voda on time given that it left Holston early. So it's the same thing as probability of Voda on time intersect Holston early all over probability of Holston early. So Voda on time and Holston early is 0.04 and Holston early is 0.06. So it's the same thing, and when you put that into calculator you get 2/3. B. Given the bus arrives late in Holston, find the probability that left Voda late. So probability of Voda late given Holston was late as well. So it's probability of VL intersect HL over probability of HL. So Voda late and Holston late is 0.04 over the probability that it arrives at Holston late is 0.25. which is equal to 0.16. 3 consecutive days for this bus service are monitored. Find the probability that these 3 days the bus arrives arrives early once, late once, and on time once. So that means we have to do probability late, Volta, toasted, so arriving, so it's Houston, early, intersect, Houston, early, Houston on time, Houston late. All the different combinations you can get for this. You get 6 lots of combination. So 6 times the probability of arriving early at Houston is 0.06 times Houston as on time is 0.69 times Houston late is 0.25. Now you get 6 different combinations because you can have HE, HOT, HL, and then you can have HE, HL, HOT, HL, HE, HOT, HL, HOT, HE, and the last 2 combinations are HOT, HL, HE, and HOT, HE, HL. So all these 6 different combinations, each probability is the same. So when you put this into your calculator, you get 0.0621. Okay, next question. Use a Venn diagram to explain the following formula. Probability of A union B union C is equal to probability of A plus probability of B plus probability of C minus probability of A intersect B plus B intersect C plus C intersect A. There's a square bracket around all those, so just be very careful to take away all of this, plus probability of A intersect B intersect C. So if I draw my Venn diagram, so we've got A, we've got B, and we've got C. So A, B, and C. So probability of A is this, this. Okay, plus probability of B is this, this, and this. I feel like I've missed one out for A, which was that one. So that's probability of B plus probability of C is that one, that one, that one, that one. Okay, now you can see that's more than A union B because we've included some parts more than once. Because remember, A union B means we have we select all the parts of the 3 circles only once. So what I need to do now is I need to take off probability of A intersect B. So if I take off A intersect B, so A intersect B is if I take one off, I'm going to take this one off and this one off. Okay, so I've just rubbed it off, yeah? Now I need to take off probability of B intersect C. So if I take off B intersect C now, so B intersect C, I need to take one off and one off there. Okay, and the last thing I need to take off is probability of C intersect A. So if I take off C intersect A, oops, undo. Yeah, you can see I've got every part once, but I still don't have this middle part. This middle part, I've removed all the ticks, so I need to include that part again, which is adding on probability of A intersect B intersect C. So this formula does work. It's useful to know in an exam, but if you can't, you can do it via logic as well. Okay, 2 more questions to go. Each of the 30 students in a class plays at least one of squash, hockey, and tennis. 18 students play squash, 19 students play hockey, 17 students play tennis, 8 students play squash and hockey, 9 students play hockey and tennis, 11 students play squash and tennis. Find the number of students who play all 3 sports. Okay, so part 1. So if I draw this out, let's call it squash, hockey, and tennis. So if I do probability of squash plus probability of hockey plus probability or number. Let's just do numbers, yeah. So if I do S plus H plus T is equal to 18 plus 19 plus 17 is equal to 54. So what I've done there is squash. When I've done squash, I've included all of this. When I've done hockey, I've included 1, 2, 3, 4, all of this. And when I include tennis, I've included 1, 2, 3, 4. So what I've done is 54. We know all the students are up to 30. So 54 minus 30 is equal to 24. So all the overlaps are equal to 24. So overlaps equals 24. Now in this case, my overlaps are, so how much have I increased? So if I draw my diagram out again, I've included this one extra time, one extra time, one extra time, and I've included this middle part twice. Okay, so the overlaps, all this part must be equal to 24. Now if I work out probability of, so squash hockey plus hockey tennis plus squash tennis is equal to 8 plus 9 plus 11, which is equal to 28. So what I've done there is, if I draw it out again, that I've included, if I do squash hockey, so this is squash, hockey and tennis, then squash hockey once, hockey twice once, and squash tennis once. I've included the middle part 3 times. So this is equal to 28. So the middle part I've included 1 extra time. So that means the middle must be equal to 28 take away 24, which is equal to 4. So the middle must be equal to 4. So now if I draw the diagram out, so that means probability of, sorry, let me just work it. The answer is, for part 1 is probability of S intersect hockey intersect tennis is equal to 4 out of 30. So squash, hockey and tennis, squash is, the middle is 4. So we know squash and tennis is equal to 11. So 11 take away 4 is 7. So this part must be 7. Okay, hockey and tennis 9. Hockey, squash and hockey and, I'm in the wrong place. So squash and tennis is 11. So this part must be 7. Hockey and tennis 9. So this must be 5. 8 students play squash and hockey. So this must be 4. 17 play tennis altogether. I've already got for tennis 9 plus 7 is 16. So that must be 1. 19 students play hockey. I've already got 8 plus 13. So this must be 6. And squash is 18. I already have 15. So this must be 3. Okay, remember, everyone plays at least once. So there's nothing on the outside. So that would be my diagram. Okay, so part 2 now. Given that this student plays squash, find the probability that this student does not play hockey. So probability of not hockey given squash, which is equal to probability of not hockey intersect squash over probability of squash. So not hockey and squash is equal to 10 out of 30 all over not squash is equal to, so probability of squash is equal to 18 out of 30. So if I put this into my calculator, I end up getting 5 over 9. So I'm going to say that again. Given that the student plays squash, find the probability that this student does not play hockey, not hockey given squash. Use the conditional probability formula, substitute your values in. get your answer. Okay, part 3. 2 different students are picked at random from the class, one after the other, without replacement. Given that the first student plays squash, find the probability that the second student plays hockey. So probability second player plays hockey given first player plays squash. Now there are 2 different cases. So first case is first person plays hockey as well as squash. And second case is first person does not play squash. Okay, so that means what we end up getting is probability that second player plays hockey given that the first player plays squash, so S1, is equal to the probability that the first player plays hockey given the first player plays squash times by the second player playing hockey given that the first player plays hockey and squash. So this is the first player and this is one for second player. Plus the other option, which is probability that the first player does not play hockey, given that they play squash, times by probability of second player playing hockey, given that the first player does not play hockey, intersect, they play squash. Okay, so H1 given S1 is equal to, because we already worked out from part 2, is 5/9 for not hockey given squash. So hockey given squash will be the complement of that, which is 4/9. Okay, and then it's equal to times by second player playing hockey given that the first player plays hockey and squash. So now there's 29 people remaining. We picked a person that already plays hockey. So hockey was 19 altogether, so there's one less, which is 18 now. So that would be it. That's the first combination. Second combination will be not hockey given squash is 5/9, which we worked out. And because this person does not play hockey, then the number of hockey has not changed, which is 19. Out of, obviously, there's one less person, which is 29. Now, if you put that into your calculator, you end up getting 167/261. So that would be your answer for that question. And that question is quite complicated. So have a look at it again if you need to. Okay, last question. The Venn diagram shows the probability of student lunchboxes containing a drink, sandwich, and a chocolate bar. D is the event that a lunchbox contains a drink. S is the event that the lunchbox contains sandwiches. C is the event that the lunchbox contains a chocolate bar. U, V, W are probabilities. Write down probability of S intersect not D. So A, probability of S intersect. You can see S is wholly inside D. So everything in S is also in D. So probability of S intersect not D. So there is no part of S that is not in D. So it will be 0. One day, 80 students each bring in a lunchbox. Given that all 80 lunchboxes contain sandwiches and a drink, B, estimate how many of these 80 lunchboxes contain a chocolate bar. So B is probability of chocolate bar given that the lunchbox has a sandwich and a drink, which is equal to probability of C and S and D over probability of S and D. Now chocolate and sandwich and drink overlaps at here, which is 0.27. So that is the intersect, 0.27. Sandwich and drink both together is just 0.33 plus 0.27. which gives us a value of 0.45 in our calculator. Given that the events S and C are independent and probability of D given C is equal to 14/15, calculate the value of U, V, and W. Okay, C. So S and C are independent. So S and C are independent implies that probability of S intersect C is equal to probability of S times probability of C. So probability of S intersect C is equal to S intersect C is 0.27. Probability of S is equal to 0.6 times probability of C is 0.27 plus V plus U. Okay, which means we end up getting 0.27 is equal to, let's divide by 0.6. So when we divide by 0.6, 0.27 divided by 0.6 is equal to 0.45. So 0.45 is equal to 0.27 plus V plus U, which means V plus U, if I subtract 0.27 from both sides, I get 0.18 is equal to V plus U, which means V must be equal to 0.18 minus U. Let's call that 1, equation 1. Let's use the second statement, which is probability of D given C is equal to 14/15, which implies probability of D intersect C over probability of C is equal to 14/15. D intersect C is equal to 0.27 plus V, where probability of C is 0.27 plus V plus U is equal to 14/15. Let's cross multiply, which means 15 times 0.27 plus V is equal to 14 times 0.27 plus V plus U, which means we get 15 times 0.27 plus 15V is equal to 14 times 0.27 plus 14V plus 14U. Let's subtract 14 lots of 0.27 and subtract 14 lots of V from both sides. So end up getting 0.27 plus V is equal to 14 is equal to 14U. So that's our second equation. So if we substitute 1 into 2, then we end up getting 0.27 plus 0.18 minus U is equal to 14U, which means 15U is equal to 0.45, which means U is equal to 0.03. Now we know what U is equal to, then V, using 1, we have V is equal to 0.8 minus U, which is equal to 0.18 minus 0.03, which is equal to 0.15, which implies V is equal to 0.15. Now that we know what U and V are, the sum of all the probabilities, which implies W must be equal to 1 take away 0.33 minus 0.27 minus 0.15 minus 0.03, which means W is equal to 0.22.